Okay, we come now to a new model, the broadcast channel. So in the broadcast channel, you have one encoder and two decoders. And in the most general case, we have three sources, source 0, source 1, and source 2, producing W0, W1, and W2. And the two decoders have different goals. So decoder 1 wants to decode W0 and W1, and decoder 2 wants to decode W0 and W2. That means decoder 1 at the end make an estimate of W0, the first estimate of W0, and an estimate of W1. And the decoder 2 make also an estimate of W0, that's the second estimate of W0 here, and an estimate of W2. Let's go through the details. So what I explained to you, the source put out the statistical independent messages W0, W1, W2. Of course, we have NR0, NR1, and NR2 bits. So the message W0 is designed for both things. And it is sometimes the common or the public message. And the message W1 and W2 designed for thing 1 and 2 respectively, and they are called dedicated or private messages. So private is not a good word because it's used if you do it with some privacy, but this is not given here and even not proved here. So I will call it always dedicated message. But if you look in some books, then you find this as private messages. So the goal is that the encoder maps W0, W1, and W2 to a sequence XN, that's done here, and send it over the channel to Y, from X to Y1 and Y2. The channel puts out two sequences, Y1 to the N and Y2 to the N. Then the decoder 1 uses Y1 to the N to compute his estimates, W0 of 1 and W1 hat of W0 and W1. And the decoder does the same for W2 to the N to compute his estimates, W0 hat of 2 and W2 hat. And the problem is now to find rate tuples R0, R1, R2, for which we can have that the error, that means that the estimate of W0, the first estimate of W0, the second estimate of W0, the estimate of W1, and the estimate of W2 is not equal to W0, W0, W1, and W2. That this error goes to 0. And you will see that this problem in general is unsolved. There exist some achievable regions and there exist some upper bounds, but they don't match. So no one knows the capacity really. What we will do look at special cases. First, we will look at the case where we have only a common message for both decoders. Second, we will look at if we have only two dedicated messages for decoder 1 and decoder 2. And then we will come to the general case. And you will see for the general case, we again need some new method. So the broadcast channel, I think it's even obvious you have important applications. So you can consider, for example, the design of a base station of a cellular radio system. And if the base station transmits to two mobile stations, a model described the essence of the coding problem. One can easily extend the model, include 3 or more mobile stations. So if you know how it works for 2, then of course you can generalize it for more stations, for more decoders than 2 decoders here. And here it's written what I already told you. There's a lot of research still, active research also, on the binary, on the broadcast channel. And the problem is still open. And we will study the problem focusing on special cases. And the theory of each cases give insight how one should code in general.